Let us solve some question. We will start from this question. It seems to be difficult, but it is very simple. If you recall, if you remind the laws of indices, you can solve it easily. What? First, we will start from there. X to the power minus 4. What is this? It is the square root. Here nothing means it is 2, you know. So, it is the square root of x to the power minus 4. First, what we can write x to the power minus 4? We can write x to the 1 by x to the power 4, as we know a to the power minus n is equal to 1 by a to the power n. So, x to the power minus 4 is equal to 1 by x to the power 4. And what is the square root of that? Square root of 1 by x to the power 4 is 1 by x square. So, this we know it is 1 by x square. Now, what is the square root of x to the power 6 into that means 1 by x square. You know x to the power 6 by x square. What is this? Just think, laws of indices. What we know, a to the power m by a to the power n is what? A to the power m minus n. So, here it is x to the power 6 minus 2, x to the power 6 by x to the power 2, just like this. So, it will be x to the power 6 minus 2. So, it is x to the power 4 is equal to x square. So, up to this we get x square. Now, x to the power 8, the square root of this means x square, and it is the fifth root of that. What is this? What we know from the laws of indices, a to the power m into a to the power n is equal to what? It is multiplication, a to the power m plus n. So, it is x to the power 8 plus 2. You can relate the laws to that. Okay, x to the power 8 into x to the power 2 is equal to x to the power 8 plus 2, that is x to the power 10. Now, what we can write? Nth root of that, nth root of a to the power m is what? A to the power m by n. So, the full problem we can apply 4 of laws in the full problem. See, nth root of a to the power n is a to the power m by n. So, we can apply here what? X to the power 10 by 5. You can relate, I think. So, what is that? X square. So, the answer is x square of what? Of this problem. So, this problem, the answer of this problem is x square. How we get? Just part by part. This is x to the power minus 4. We can get applying law of indices. So, the square root of this is that, and then this we can get x square, and finally we can get the answer is x square. The second problem, simplify x to the power b by x to the power c to the power 1 by bc, x to the power c by x to the power a to the power 1 by ca multiplied x to the power a by x to the power b whole to the power 1 by ab. How we can simplify? So, we will apply the laws of indices and then we will solve the problem. How? Solve with me. What will be that? X to the power b by x to the power c? Can you say that will be x to the power b minus c. How? Because a to the power m by a to the power n is equal to a to the power m minus n. We know a to the power m by a to the power n is equal to a to the power m minus. We have applied this and we can write what? X to the power b by x to the power c. So, it is x to the power b minus c whole to the power 1 by bc, as well as it will be what? X to the power c minus a, and it will be x to the power a minus b. Am I clear? Now, another one, laws of indices we have to apply. What will be x to the power something whole to the power 1 by bc? We know what? Isn't like a to the power m whole to the power n? How we can apply? It is x to the power something to the power that. So, it is like which law? A to the power m whole to the power n, and we know it is a to the power mn from the laws of indices. What? A to the power m into n. So, just we will apply and solve it. What? X to the power then b minus c into 1 by bc mn, and this is x to the power c minus a into mn e to the power mn, and it is what? So, we can write clear? So, now we have to simplify that. How? Here we can write x to the power b by bc, that is b cancel. So, it is x to the power 1 by c minus c cancel, it is 1 by b, and here similarly c cancel, it is x to the power 1 by a minus a by ca, a cancel 1 by c. Similarly, a by ab, a cancel, x to the power 1 by b, and minus b by ab, bb cancel, it is 1 by a. Now, you have to think here which law you have to apply here. It is like a to the power m into a to the power n into a to the power something else. Suppose this is m n q. So, what? We know a to the power m into a to the power n is what? A to the power m plus n, isn't it? A to the power n into a to the power n is equal to a to the power m plus n. The power will be added. So, here it is a multiplication, base are same, x is the base, different power, it is multiplication. So, what? Power will be added. 1 by c minus 1 by b plus 1 by a minus 1 by c plus 1 by b minus 1 by a. So, what? X to the power 1 by c minus 1 by b plus 1 by a minus 1 by c. See, 1 by c minus 1 by c minus 1 by b plus 1 by b plus 1 by a minus 1 by a. So, here is nothing but x to the power 0. And what we know? What is a to the power 0? You all know it is 1. So, the answer is 1. Another one example is if PQR is equal to 1, the condition is given, we have to show that 1 by 1 plus P plus Q to the power minus 1, that is Q inverse, plus 1 by 1 plus Q plus R inverse plus 1 by 1 plus R plus P inverse is equal to 1. So our motive is how can we make it 1? So the denominator, if we can make all the denominators are same, so one chance is there to make it 1. So let's see what to do. We will go part by part. If we think that is the first part, second part, third part, okay. So it is 1 by 1 plus P, and Q inverse we can write 1 by Q. So what is this? After simplifying, we can write Q by Q plus PQ plus 1. I think it's not so difficult, it's very simple. After simplifying, we can get. Now, what is the condition here? It is given PQR is 1. So PQ, what is PQ? PQ is 1 by R, that is R inverse. Is that clear? So we will just put Q plus PQ is R inverse plus 1. Now see the denominator of that part, what? It is same as the denominator of the second expression. What is that? 1 plus Q plus R inverse. So we will keep the second expression as it is, okay. We will not simplify this because the denominator is same. So just go for the third expression. So we will write here, it is 1 by 1 plus R plus P inverse, okay. So I'm just repeat again. So what first expression we got that in which the denominator is same as the second expression. So we will keep it as it is because the denominators are same. So we will switch to third expression. What? We will simplify and we will try to make the denominator same as that. Our motive is we will try to make the denominator same as that. Am I clear? What? Simplify this. 1 plus R, P inverse, which means 1 by P. So after simplifying, we will get P plus PR plus 1. Is that clear? Very simple. After simplifying, we can get this. And what is PR? From the given condition, PR is 1 by Q, that is Q inverse. I think it's very much clear. So what? P plus PR, that is Q inverse plus 1. But still now the denominators are not same is like that. The denominator is not same like that. So we have to make it. How? See. So what we have got after simplifying the first expression, we have got this. We have kept this as it is, and after simplifying the third expression, we have got this. So now left hand side, what? The first expression is equal to Q plus R inverse plus 1, second 1 plus Q plus R inverse, and the third so the denominator are same for all the expressions. Q plus R inverse plus 1, Q plus R inverse plus 1, Q plus R inverse plus 1. So we can write it as Q plus R inverse plus 1 and Q plus 1 plus R inverse, which is same, Q plus R inverse plus 1, Q plus R inverse plus 1. So numerator and denominators are same. So it is 1, which is the right hand side.